Contestants, find the limit of this equation.
Calling somebody else fat won't make you any skinnier. Calling someone stupid doesn't make you any smarter. And ruining Regina George's life definitely didn't make me any happier. All you can do in life is try to solve the problem in front of you.
The limit is -1.
Oh, crap. I lost.
That answer is incorrect. Now, we are in a sudden death. If Miss Heron can answer this problem correctly, we have a winner.
Limits. Why couldn't I remember anything about limits? Limits. That was the week Aaron got his haircut. Oh, God, he looks so cute. Okay, focus, Katie. What was on the board behind Aaron's head? If the limit never approaches anything, the limit does not exist. The limit does not exist!
Our new state champions, the North Shore Mathletes.
How do you like me now?
All right, I'll tell you what, really impressed with you guys attempting this and even what you're showing. Okay, shows a lot of growth. Good job. You actually will see a problem like this on the tests down the road. Even if you made a little mistake here and you're going to fix it, I hope that you are able to still do a nice job with it. Like, don't forget about this moment right now, because it seems like people do pretty well in class. Just don't forget this when you get to a test. Anytime you see something that you know the answer to, anytime you see the sine of x over x, it's just kind of catch your attention. It should be something you're like, oh, I could split this up. Now, most of you have this split up correctly, but for some of you, it's just a little algebra. But I just want to be here and say, hey, that's good algebra, that you take x and you divide it to both, you split it to both. So we do have to do the algebra correctly. Just by the way, if you weren't at the spot where you were doing the algebra, it's just kind of one of those things that you have to recognize from maybe the last time, and that is that you can get sine of x over x. And I'm just saying, if you can get that, that's good, because you know the answer to that. Now this cancels, so we should keep doing algebra. Now, I'm guilty of this also. Like I said, I'll never take off for this, but technically, I'm trying to do the limit of what's happening here. So technically, it's now time to think about the limit of the sine of x over x. And as some of you did, you put a little box around it because you know that limit. Okay, you know that limit because that graph does that goofy up and down thing, and eventually it gets closer and closer to 0. Okay, at least that's what it's intending to get to. How about the limit of 3? Okay, well, that will always be 3. It will always intend to be 3 because it is 3. Okay, so kind of without a calculator, we arrive at the number 3. Now, there's really only one thing different about this one. And again, this is what I want you to remember. Try to remember this moment. I didn't really get to look at everybody's paper here, but this is the part that's different. The sine of x over x is now the limit. We're now talking about the limit as x approaches 0. Are you kind of like picturing a different part of the graph? Do you realize it's a different answer? This time it's going to be 1. It's going to be 1. Okay, now that's that part of the graph where it goes up and there's a little hole in the graph up there, and then it goes back down. But that's why we get the number 1, because x is approaching 0. The limit of 3 is still 3. Now, if we're going to compare and contrast, one thing we want to understand here is that one of these answers represents an asymptote. Okay, with me just saying that, do you realize which one is the asymptote? It has to be the one that involves infinity. Okay, so if we were going to graph this, I'm going to skip doing the graph on my calculator, but you should see the graph approaching an asymptote of 3. Actually, here, I don't want to skip it. Let's take a quick look. I saw some of you graphing it, which I like. Just make sure we're graphing it correctly. Anytime you have a numerator, you got to put some parentheses around it. Notice also that I'm graphing the original problem. I'm not graphing the canceled version. I got to go back to the original problem. Okay, so we type that in. I'm going to hit Zoom Trig, kind of wondering myself what might happen here, but I'm going to hit Zoom Trig. And it's basically that similar graph, that graph that's going up and down, but it has shifted up, and it's shifted up so that now the asymptote that it's going to eventually bounce back and forth is up at 3. So that's good. There is going to be an asymptote there. It might help if I go a little further. I know that there was a time where I took you guys to infinity, like if I make the x value bigger. If we do that, we can see for sure that there's an asymptote. And then the other thing is that we have a limit of 4. And it's a little hard to see. We have a limit of 4 when x approaches 0. And that red dot should actually be an open circle, okay, because there's a hole in the graph up there. But the intended value is 4. Anything else with that? Okay, good. It's just kind of something to tuck in there. Now, let's kind of officially finish up this lesson here. And as I mentioned, I want to talk to you a little bit more about infinity, a place that we've actually been before. But you'll see why we're coming back to it. All right, so we have a limit as x approaches 3 of 2x squared over x minus 3. Let's kind of just talk about it together, because sometimes people are like, we did do this. Okay, so notice suddenly I'm back to x approaching an actual value, like an actual constant. And the truth is, and actually saw some of you do this on that problem over there, which wasn't a bad idea. But here, we need to plug in 3 so that we can observe something. So I'm plugging in 3. Okay, remember, a substitution strategy should always be your first thought for a limit as x approaches c. And don't be too quick to kind of throw this one out. The truth is, when you get 18 over 0, we want to remember that that is telling us something. And it's not telling us that it's an indeterminate. In other words, we actually can determine the answer from this. Okay? Remember, when you have a 0 in the denominator and basically a non-zero in the numerator, when you have a 0 in the denominator, that means that this number right here has always been a vertical asymptote. A vertical asymptote. And just like Miss Karen on the video, as we already know, what is the y value doing as you get close to a vertical asymptote? Well, it's always been going to infinity. It's always been going to infinity. Now, again, I want you to notice that we can give an answer as infinity, but that means that the limit does not exist. And as we said yesterday, I believe, but at some point I said that both those answers are fine. They both kind of tell you something different. This one tells you that the graph goes, the y value goes on forever. This one tells you that there's really no limit. There's no y value. Now, the vertical asymptote, different than a horizontal asymptote. It also allows us to have a quick conversation about a one-sided limit. Make sure you can see what I'm writing. I just put the limit as x approaches 3 with a little negative sign. And I also am going to put the limit as x approaches 3 with a little plus sign. So that we can have this little conversation. And that is, you will always have access to the graph when I'm asking you about a one-sided limit. I am not expecting you to know what the graph looks like so that you can look on the correct side. But let's look at the graph so we can look on the correct side. By the way, I just hit zoom standard. Zoom standard, I'm not graphing a trig function. Now that graph should alarm you a little bit because from some prior knowledge, you are looking for branches. We have one branch. We have the branch that is on the left side, and we can see that on the left side, the y value is going down. And what I'm trying to say here is we can actually be more specific and now say that the answer is negative infinity. Again, we can be more specific. But where's the graph on the right side? Okay, this is where this should alarm you a little bit. And that is when you have to go play a little more. You have to go search. And that means changing the right side of the window to be a little bigger. Now, you say, well, why are you changing it to 15 and 30? I'll just let you know that I'm just kind of guessing. I actually forget what this problem's like. I figured I need to see a little more X, and I thought I need to see some more Y. I don't know exactly how much, but I'm going to give it a shot. And it looks like I saw enough. I can see that the right side of the graph is going to positive infinity. Okay, positive infinity from the right. Now again, notice that I'm being more specific with my answer, which is something that you can do when given a graph. Make sure you kind of get my drift here. That is that vertical asymptotes are also, will also involve infinity, but in a different way, okay? Because now it's the limit that equals infinity. What you're seeing up here on the screen, you may want to jot down, but you may also feel a little bit like you've seen it before. So just take a look at it. Again, with a vertical asymptote, it's the limit that equals infinity. We're putting the infinity sign in a different place. Now, if it's starting to cross your mind that there's kind of like a lot of ideas floating around, definitely. We have limits equaling infinity. We have a limit as x approaches infinity. We have horizontal and vertical asymptotes. I'm kind of purposely giving you this information. I'll let you know that mainly after lunch, you're actually going to organize it. You're going to organize it through a little class challenge. And I really think that by the time you leave today, you'll feel like no matter how you guys do with that class challenge, that you're starting to able to put this together, which I will help you do with a little chart. And again, I just don't want you to feel overwhelmed if you're kind of like, geez, how do I do all these problems? So we're going to do this chart. I'm guilty of this. I'll show something on the calculator, but then I may not put it on the board. But I'll say that you can put it in your notes. I'm trying to be a teacher that guides you into becoming who you need to be. If you felt like it would have been a good idea to draw a sketch of that last problem, that was a good feeling. If you see it on the calculator, you may want to sketch it. I'm trying to help you think that way. So again, I looked at the graph, I saw negative infinity. I looked at the graph and I saw on the right that it was positive infinity. You know, whatever you need to help you keep learning, and drawing sketches may be one of those things, even if I don't draw it. Let's do one more thing with these vertical asymptotes. Sorry, I have to kind of write this out just so you can see it, but here's the main thing: x over 4 minus x squared. So we're trying to find the vertical asymptotes for f of x equals x over 4 minus x squared. Now, not to state the obvious, but we don't have the word limit written up here. So I'm not asking you to find the limit, but I'm asking you to take some ideas that were presented in the last 10 minutes and see if you can find the vertical asymptotes. I don't want you to panic if you're like, oh, I'm not sure. Because I think when you see it, you'll say, oh, I can do that. Now, if you're looking at a graph, that's fine. You're using your resources. That's what I want you to be. You got to use your resources. There is a way to do this without the graph, and it's just by noticing that there'll always be a 0 in the denominator. There'll always be a 0 in the denominator. Look, we could connect the dots a little bit more here, which maybe you want to do. The reason there was a vertical asymptote was because we had a 0 in the denominator. So what gives you a 0 in the denominator? It might be easy enough just to look at it, but you can always make a little equation and you can solve that little equation. And when you solve that little equation, you get 2 and negative 2. Don't forget the plus or minus. We end up with 2 vertical asymptotes. Now, if you looked at a graph, you would have seen, and I like to say maybe not be surprised, that you would have seen a graph that was approaching each of these vertical asymptotes. Geez, I kind of forget what it looks like. Did you look at it? What's happening?
It's like the regular tangent line that crosses the origin, and then it looks like it's like a horizontal asymptote at 0.
Are we positive or negative here?
Yeah, and then
Same, just reflected.
Yep.
Negative.
No, positive. Yeah.
All right, so there's 2 and negative 2. Now you ready? This is like the next level of thinking. This is why you came to class today. Can you write a limit statement? Check that. Can you write multiple limit statements about what's true about this problem? What's true about this? Or maybe what's true about this? But can you write a limit statement? Okay, this is like a new place. I've always been the one writing them. Go ahead and see if you can do some of this before lunch. I don't want to ruin your fun, but if you're like a little stuck, sometimes you just got to get started by writing the limit as x approaches. So there's a little template. There's more than one limit statement. If you wrote one, can you write another one? I hope you're using infinity more than once in your statements. Now look, I'm glad you tried it, okay? There's some right answers out there. Just to be honest, there's some answers that aren't right, but that's how you're going to learn. And you know, there's even more answers than what we're given. You might realize that, again, it's a pretty wide open slate here. How about just the vertical asymptotes? Let's kind of stick with the vertical asymptotes. You would have to have x approaching the vertical asymptotes. Okay, now there's different ways to say this. You could lump this all together into one statement. You could say the limit as x approaches the vertical asymptotes would have to equal or. So just saying those things are all true, okay, because as x approaches 2 or negative 2, my graph is going to infinity or negative infinity. Are there any other variations of this? There are. Do you have one? We're not going to put them all down, but I'll show you one. If we want to get specific, we could say as x approaches 2 from the left.
F of x equals pi.
Okay, now make sure that you guys realize that Bryce is looking right here. Okay, this would be where we're looking from the left as x approaches 2. So that would be true. We could talk about from the right. We could do it for this one. Okay, so we have those variations. The limit as x approaches infinity. First of all, I'm glad that a lot of you wrote it down. This is the one where some of you have a mistake, but we can learn from it, okay? What are you looking for as x approaches infinity? Not a vertical asymptote, right? Okay, and Delaney was actually the one that said it. I sort of didn't say, when you said it, you were right, that it looks like there's a horizontal asymptote. It looks like there's a horizontal asymptote. There is. Well, at 0. Okay, now that's your limit. Your limit is your horizontal asymptote. Okay, that one's a little more straightforward. There's really no more variation on that unless you wanted to put a plus or minus right here. A plus or minus right here would imply that it's happening on both sides. So that's true. But the main thing is it's the asymptote. When you guys come back, is the bell going to ring? Okay. When you come back, we'll show you what